Hi class, welcome to our lab on correlation, simple regression, and multiple regression. We're going to get started with just looking at where things are in Canvas. If you go to your relationships among variables page and to our first tab, which is simple and multiple regression, this is where your materials will be linked, and we'll also put links in the description of the YouTube for you. So what I have open right now is the lab sheet and SPSS and the starter tables Excel. So going to this. So what we're doing with correlation, simple, and multiple regression is getting started with evaluating regressions and the assumptions that go into knowing when that's the test that you should be running. We're going to use the research methods instructor dataset for this lab, and you can find it in the datasets tab or linked in the description. So your datasets tab is right there in Canvas. And the research methods instructor scenario basically is the research methods instructor gave 3 of his classes a survey about their perceptions regarding research methods. And he did this survey twice, once at the beginning of the term and once at the end of the term. So it gives us some fun things to look at, both pre-post or 3 different classes. It also has different personality, cognitive ability, some dichotomous variables, things to look at. So it's a fun data set to play with. So our RQ for this lab are personality factors, significant predictors of students' perceptions of research methods. And we're going to hypothesize that we expect conscientiousness and cognitive ability to be predictive of students' perceptions. Our study variables of interest here are the big 5 personality traits, cognitive ability, and the outcome variable of perceptions of research methods at time 2, so at the end of the term. The tasks we want to get into are to create a correlation table of all of the continuous study variables, so running our correlations and building a correlation table as part of describing. And then we're going to evaluate assumptions that are related to regression, namely, are the predictors normally distributed, and do we have bivariate linearity? Is there a linear relationship between the predictor and the outcome at all? After that, we're going to conduct 2 simple bivariate regressions, so 2 separate regressions that only have one predictor in them each. And then we'll conduct a multiple regression that has 2 predictors with the outcome. And along the way, we are interpreting results and gathering relevant information from the output so we can communicate our findings. The materials you're going to need for this, the data set is called RMI version 2 DAT, and that's a tab delimited data set. We're also going to work with some Excel tables and building that correlation table. And it's handy to have that code book for the research methods instructor, which is back on that page. If you follow the code book, it takes you to what the variables are. So we are working with our personality factors, cog ability, and then perceptions of research methods at time 2. And they're all continuous, which is one of the assumptions of regression, is that your predictors are continuous. Okay, let's get started. So, as I mentioned previously, I want to have you read the data in to SPSS and into RStudio later, different types of data, so that you get some experience with how these might look differently coming into those analysis programs. For SPSS, when we are trying to open a tab delimited file, we will import the data and go to text data. So File, Import Data, Text Data. Here we'll get our little dialog box to go find where you put the data. So that's why you need to save it in a place that you know where to find it. When you open the file, it's going to start with this text import wizard. And what you're looking for here is just to make sure SPSS realizes it's tab delimited data. So you just go through the questions and answer them. I don't have a predefined format, so I'm going to go to next. Delimited variables are delimited by a specific character, such as a comma or tab. Yes, that's what I want. Are the variable names at the top of my file? Yes, they are. What is a decimal symbol? Because in European countries, a comma might be used as the decimal. We want to let SPSS know that a period is the decimal. The first case begins on line 2. Yes, because the first header row is just the variables. Each line represents a case. I want all the cases, and it kind of gives you an idea as to what it might look like. Right now, it says which delimiters appear between variables, and it thinks that tab and space are delimiters, and that's not the case. So I want to turn off space. And if you notice this bar right here, if space is included, it's importing a lot more variables. It's because there might be a space in like a string variable or something, and that's going to misalign the variables. So I need to make sure space is turned off because it's only tab that is setting apart each of these variables. Now I can hit next. And I usually don't set this up here. I just go through and make sure the variables are on the right measurement after I get them into SPSS. So I just go by this one. Would you like to save this for future use? Not really. I'll just take it, I'll look at it when it's importing. Would you like to paste the syntax? Yes. So we'll finish here. It's going to open up our syntax window, and then I'm just going to take the whole thing and run it. So this is our import process. And our output window for importing this data set, this tab delimited data set. But I'm interested in, there we go. I'm interested in the data frame here. So what of these do I need to fix? Well, case ID on my variable tab, variable view, I need it to be a nominal variable, right? I'm not too worried about my categorical variables because we're not working with them today, but I do see that they're all nominal. And then I want age is scale, openness is scale, all of those are right. Cog ab total should be scale. And then notice all these different sizes of widths. It's going to help to just set the width standard So let me pull this over so I can see my directions at the same time. So I want the width at 5 and the decimals at 2 for the continuous variables. So I'm not worried about the categorical, but this can be to all of these that came in really high. It's probably a repeating decimal, and that's why it came in that high. But all of these can be 5, just to keep it all standard. And then what else do I have? I can set the column width to 8 on all of these. There. We're good there. Let's see. This is scale. These are nominals. This is scale. This is nominal. College year is actually ordinal, but we're not working with it today. But let's fill in our labels. This is easiest done by just copy paste from the code book itself. So if I go over to the code book, and right now it's in the same order as the data set. So from case ID, then the personality attributes, then COGAB, then the dichotomous variables, and then the outcomes of time 1 and time 2, perceptions of research methods. All I did was copy the labels there. And then in here, I can, oops, just paste them all. I'm going to do Control V, and then that's all my variable labels. Let's make sure we don't need to set values because we're not going to be working with the categorical variables. But when you do set variables and do syntax to establish variable names and values, you might want to save that syntax so that if you need to add that information in, you can do it quickly just from your syntax. But we're ready here, and this is a good place to save your data set. Alrighty. So our next preliminary task, and again, those preliminary tasks are getting your data ready for analysis, making sure the variables are on the right type of measurement, making sure they're recognized and you know what they are. But then we go into describing the variables. And because we're talking about all continuous variables, what we want to describe is the mean and the standard deviation. We also want to build a correlation table and be able to give the reader information about the relationships among these study variables. So to build a correlation table, we're going to go to Analyze, Correlate, and Bivariate. Here we're going to put all of our variables all of our study variables into the variables box. Whenever you have the labels coming up like this, you can right click and do display variable names. That often keeps it a little cleaner. And I'm going to cancel this for a minute and go over to edit. And in options, you can set this up so that it's always displaying names, and in the output we're getting the names and the labels. And that way you don't have to fight it each time trying to figure out what's what. So Analyze, Correlate, Bivariate. Here I want all of my study variables, which we listed them in here. All of these are the study variables. So I want all of those in this box to get correlations between the study variables. All right, and then let's see if I want anything else here. In options, ask for means and standard deviations. This one. That way it'll go ahead and pick up that information that you need for continuous variables while you're getting the correlations anyway. I'll hit continue here and then paste. And of course that goes over to my syntax window. And there it is, activating the data set and asking for correlations, the variables list, and that I want descriptives as well. So we will run that. All right, here's our correlation table. And as mentioned before in lecture, this is a repeat, like this diagonal, where you see the ones along the diagonal, all the numbers on the lower triangle are just repeated on the upper triangle. So you only have to read half of this table. So which relationships are significant? How do we determine the effect size of a correlation? And how do we build the correlation table? I put a visual for you in here in the lab sheet, where we can see that asterisks indicate significant correlations between two variables. And again, we only have to worry about half because the other half is just a repeat. So here they're circled so it's easier to pick them up visually. We have a significant correlation between agreeableness and openness to experience. We have a significant correlation between cognitive ability and conscientiousness. We also have a significant correlation between perceptions of research methods and conscientiousness. And then over here, cognitive ability is also related to agreeableness and neuroticism. And this one is in green because that's our outcome variable. We want to know if something is related to the outcome variable. And it looks like conscientiousness is significantly related to our outcome variable of perceptions of research methods at the end of the term. Now, how would we go about getting the effect size? Well, the effect size of a correlation is the correlation coefficient squared, that coefficient of determination. So we would take negative 0.247 and multiply it to itself to get the R squared, the coefficient of determination for this correlation. And then how do we build the correlation table? Well, I'm going to show you what I would suggest, and you can build it however you like because it's just building a table in Word or Excel. If you build it in Excel, then you got to move it to Word anyway. And I'm going to come up here to the ribbon in Word and go over to View. I want to make sure the ruler is on so I can see the ruler. And I'm going to go to Home and turn on this. It's Show and Hide Non-Printing Characters. And that's how I can see returns. I can see where a page break is. And it helps me see what's going on with the table as well as I'm building that. Now that Excel starter table is what is already prepared if you want to use it. You don't have to. And if you look at the tab called Table Core, it's just a starter for a correlation table. So your correlation table should have the mean and standard deviation and should have that lower half of the triangle of the correlations. So we can fill this in, but notice there's only 5 variables here, and on our data set we have 1, 2, 3, 4, 5, 6, 7. We have 7 variables, study variables. So we're going to have to add a couple of rows, right? So I'm going to insert a couple rows. I'm going to put 6 and 7 here. And we won't really need the 7th row because something to itself is just going to be 1 anyway. But I'll leave it there for now so you can see what I'm talking about in a little bit. I'm going to take off that border between those so that I only have the lines top and bottom and then right there. But I do need 5 and 6. But all of this information is from a different data set. So I can delete all of that information. And I also need to update the variables themselves. So I'm going to pull this aside so that I can just see my variables and the Excel sheet at the same time. Still didn't spell it right. Let's see. There we go. Whenever you have a abbreviation in your table, you're going to have to tell your reader about it in the note. No worries about this. We can't see it because it's wrapping or because it's not wrapping, one or the other. But I'm just going to leave it there because it'll work itself out in the Word document. All right, so I need mean and standard deviation. I can get those by coming over to the descriptives table. When we did that extra check mark to get descriptives, mean and standard deviation, they're right here. So if I double click, now I can copy. I'm holding the Shift key to get all of that information, and then I'm going to right click and put copy. And then I'll go to my Excel. I'm going to hang right here on the first cell that I would want to paste, and I'm going to Control V. And that looks like it got confusing, so I'm going to Control Z. I'm going to come down here where I can paste it like safely. So Control V, and then I'm going to tell it match destination formatting. Okay, that's better. I feel more comfortable with that without it messing up my table. So I'm going to copy again and now put it in place. And that way I kind of know it's not messing anything up. Now here in these numbers, I can change how many decimals it's doing. I'm going to leave it at 2 decimals for now and let that ride for now. So now I need to get all of these correlations. If I double click this, that's all my information. What I can do is just type it in, or I can try to copy paste it in. It's a little harder to copy paste it in because of all of those rows, but I'm going to copy here and then go to my table. Now I'm pasting, but it's got all of those rows, right? Let me get it where we can get it bigger. And till it just pastes those. Now what was going on there is we had the correlation. Oh, I didn't get the top. That's not good. You see that? You got to make sure you get the whole thing. In fact, I'll just get the whole thing. Copy, copy. And then I'm going to delete these things just in case they were copied wrong. That's all I need, right? And I'm going to paste it all right there. So this line is the Pearson correlation, this row. And this is the significance level. And then this is how many. So I really don't need the significance level itself and the sample size on each one of these, not for the correlation table. I'll just put the significance level there in the note, and I'm not putting the exact significance level in the table. So all I really need on this table are the coefficients, the correlation coefficients. So I'm going to just get a lot of this out of the way. I'm holding control so that I can select rows without having it to be all the rows, because I want to get rid of just the ones that I don't want. So I'm holding control and then only clicking the rows that I'm trying to delete. Once I have them all clicked, I'm deleting them. And now I have just the correlations. And it's in the same order: openness, conscientiousness, extroversion, agreeableness, neuroticism, cognitive ability, and perceptions of research methods. Now looking at this, remember I only need the bottom half. So I can take all of these and take them out. And you see that one, that last one, that's why we're not going to need the 7th row or the 7th variable right there, because perceptions of research methods related to itself is just going to be 1. Right, these are all the correlations that I want. So now I'm going to copy this. Oops, need to get up there to openness. I keep forgetting openness. Copy. And then right here, paste. So openness to openness is just going to be itself. So you put a dash there. And when you put a negative sign like that in Excel, it thinks you're trying to subtract something. If you put an apostrophe before it, it lets Excel know that that's just a text artifact. It's not going to be a formula. So I have that apostrophe minus, and I'm going to copy it and paste it on each one of the ones that is just the variable related to itself. And I can take all of these numbers and center them. So there's all the correlations. I do still need to indicate which ones are significant, so I have to get that from the output, but now I have all the numbers in their right place. Now we had noticed on here which ones are significant, right? We have agreeableness and openness. Agreeableness to openness right there. I'm putting an asterisk at it. We have cognibility with conscientiousness, agreeableness, and neuroticism. Conscientiousness is number 2. Number 2 is right here. And cognitive ability across, that's how you know where the correlation belongs. And then neuroticism is number 5. Now that one's a negative, which means that Excel's going to think that I'm trying to take a negative number and multiply it to something. So I can get in front of that negative and put an, and now it understands that it's just a text. Don't compute it. And we need agreeableness right there. And then I have one more. I have the one that is kind of the most interesting one for us because it's related to the outcome, related to the dependent variable. And it's conscientiousness with perceptions of research methods. Conscientiousness on number 2. And then I'll put the apostrophe in front of it so it doesn't think it's a formula. Okay. So now all my numbers are in here. I want to fix this border. And I want to fix this border. It looks like it's not as thick. You notice that? See how over here the border's thin and over here it's thick? So I'm just going to take the whole thing and kind of take off all the borders and now set them straight. Bottom, bottom, and bottom border. Now, how do I know where the borders should be? That's going to be in your APA book for sure. And we do have the ability to just search for APA stuff online. APA 7 sample correlation table. So if I want a sample correlation table right there. So there's my border both on top of the word variable and under the word variable, and then one at the bottom before you get to the notes. So I'm going to go back and look at my starter and see how well it's fitting this. So did you notice that variable is centered on the example? Things like that. Look for where it might need to be fixed before you get it over into Word. For the table, the table number should be bolded, but the table title is not bolded, but it is italics. So I think I'm ready to cross it to Word. I'm going to just take this whole thing and Control C for copy. And I'm going to go to here. So I'm going to paste, Control V. And you see how it's a little too long? What I can do there, I'm going to go ahead and delete this. When you select the table using that icon to select the whole table, it opens up these extra areas in your ribbon. I'm going to go ahead and delete this table and come back to here and make all of this kind of tinier. I want that smaller. Yeah, let me see if that will cross to Word better, because I can adjust the formatting in Word on some things easier once I get there. So I have all my numbers. I've did Control C to copy. Let me try this again and paste it. It's a little closer, right? So here, let me work with this. I'm going to select the whole table with the icon there in the corner. And I'm going to go to Layout and Autofit. In Autofit, I'm going to Autofit to Window. Okay, that looks like they're spacing better. They're all staying on one line. Let me see what size this is. That's a little better. 11 worked better. I can't go too small. Like APA lets us use like 11 and 12, and we can use different fonts as long as it's consistent across the whole write-up. So whatever font I'm using for the manuscript, I want to use that same font in my tables. But this looks like a good start. I'm going to go to layout and make sure everything's like to the top or something. Yeah. And now I'm just poking around. I know that one needs to be, I'm going to pin this ribbon so that it stops going away. And on Home tab, I know variable needs to be centered. I know I want all of these centered. This column, oh look, I can put just the table number and the title separate, which saves me from having to fight these two columns or these two rows. So I'm going to delete these rows because I'll just keep the table number and title up there. And that means now I can sneak up here to where the arrow turns down like that. And I can bring this in a little tighter because it only needs to be for those numbers. This last row, I can merge it across the whole table. So merge the cells so that that last row gives room for the note. And of note, the note can be smaller. You can bring the note smaller, and because we don't have any p-values that small, p less than 0.01 in the table, we can take that piece out. You only need to report in your note the p-values that are represented in the table. Alrighty. Another thing we can do to clean this up a bit, we can turn off the show hide non-printing characters because it does make it look really busy there, and sometimes that's hard to figure out what's going on with the table. So if we turn it off, we can get a better idea on how crowded the table is. But one thing you can do in here is regression coefficients should not have a leading 0. The reason why is the range for a regression coefficient is only from 1 to 1. It's never going to be more than 1. So we don't need a leading 0 for it. In APA, if a number can have if it can go above 1, then you keep that leading 0 on it. But if it cannot go above 1, you can take off all of these leading zeros. Another thing to notice here is, do you see how some of my regression coefficients have 3 digits and some have only 2? I could make them all 2 if I need the room. I wouldn't go under 2 though. So all of my coefficients are 3 digits except for this one because it ends in a 0. So I'm going to make them all consistent with each other. My mean and standard deviation are consistent to each other at 2 decimal places. When you're writing in script, in your narrative, you want to keep mean and standard deviation to 1 place. But here in the table, it's fine to have more places as long as you're consistent, between them there. All right, that's looking good. Let's see, Calibri and Helvetica. So that's a problem because I need them to all be the same font. Maybe like that. So now I have my correlation table that I can use in a write-up, and it shows all the relationships among all the variables, all the continuous variables there. So let's go back to what we have here. Looks like we're pretty much done with that. So for model testing, we're going to start with checking out the assumptions of regression. And two initial assumptions we're checking out are that the variables are normally distributed, more or less, and that they have bivariate linearity, that they have a linear relationship between them. But normality is something we have to check out for all the variables anyway. So we're going to start by visually inspecting normality for all of the study variables using histograms, checking out outliers, and doing the normality tests. And we can do all of that with Explore, so it makes it kind of easy. In SPSS, we'll go to Analyze, Descriptive Statistics, and Explore. Here we want to get all of our study variables, so all of the personality, the cognitive ability, and perceptions of research methods. In statistics, we are good, so we can ignore that one. In plots, we want to turn on histogram. We don't need stem and leaf. And we want to turn on normality plots with tests. And continue there. And then we're ready to paste. All right, there it is. Openness, conscientiousness. There's all the study variables. And we can run this. Actually, if you have your cursor anywhere in this code that's like beside the bar in your syntax window, you can do Control R for run, and it'll run the request. So here we have, oh, it's running it. Here we go. So here's all of the variables. Openness through neuroticism, cognitive ability, and perceptions of research methods. And the descriptives about them that we can look at each variable individually. But I'm going to scroll down to the tests of normality here. And we can see which of the study variables are significantly violating the normality test. So taking note, we have openness to experience, and extroversion is violating, agreeableness, cognitive, not cognitive ability, it's not under 0.05, but perceptions of research methods is. So that's our test, but let's also look at it. There's openness to experience, and it violated the Shapiro-Wilks, but it doesn't look too bad. Like if we put a normal curve on this, right here, yep. That's kind of like it's got a high end right here, but otherwise it's trying. Like some are worse. Some are, let's see, conscientiousness, not too bad. That one's interesting. That's very spiky, right? That's probably got a very high kurtosis value estimate. Agreeableness, very negative skew on that one. And then here it also has an outlier. So in your box plots, you can see which ones have outliers to be able to tell the reader about that. And really, when you're doing the preliminary checks, you are only really reporting when something's like a violation or out of the norm. Okay, let's see what else we have here. Which variables visually seem to have issues with normality. And it's fine if what you think, hey, that looks pretty normal, and Shapiro's Wilks test is significant, saying it's not normal, it's okay to say that. Conscientiousness seemed to be relatively normal, even though the Shapiro-Wilks test was significant, indicating a non-normal distribution. We know that Shapiro-Wilks is more sensitive to any sample size like over 30, so it's going to maybe come up violated more often than we think. Which variables have potential outliers? We found that one with agreeableness. Was there any others? Neuroticism, cognitive ability does not have any outliers. But then perceptions of research methods has one down here. So those are things like when you see something out of norm in those preliminary checks, that's what you're going to let the reader know. Okay, so bivariate linearity is just saying, are the two linearly related? And here we're really focusing on those that are going to be in the regression. Like you're preparing for the regression by finding about the assumption of bivariate linearity. And we do it visually by requesting scatter plots. And we do it in a test with the correlation test. So to call a scatter plot, we go to Analyze, and then, we go to Graphs and Chart Builder. It's giving me a little warning. Before you use this dialog, measurement levels should be set properly for each variable in your chart, so that it knows if it's a continuous or a categorical variable. And that we did when we imported the data and checked out each variable. We made sure each one had the right measurement type. So here's our chart builder dialog box. We're in the gallery. We want scatter dot, and then specifically we want the one called scatter plot. We'll pull that into the gallery or into the chart preview area. On the y-axis is where you want your dependent variable, and that's going to be perceptions of research methods at time 2. And then on your x-axis is where you want your predictor. And the first predictor we're going to check out is conscientiousness. And remember, this is where we can do some edits to the figure while we're making it. So I can click on the title and come over here and give it a custom title like scatter plot between as long as I spell correctly, and I watch my capitalization because I know that figure titles need to be title case, then I could already have SPSS working on that. This already says conscientiousness, that's good. I can come over here and change that access label to perceptions of research methods, like that. And then I'm going to hit OK here. And now I have my scatter plot between perceptions of research methods and conscientiousness. Now, some other things I can do to make this kind of illustrative for the reader is if I click into it to get the chart editor, I can add a line, a fit line. And what I want is the linear fit line, but take off the attach label and apply that. Can close this box because I closed this so that that gray goes away over there. And now I have a line. I can see there's a negative trend. It's like easier to see with the fit line there. Let's see what else. it looks like we have a negative trend on the relationship between conscientiousness and perceptions. So I can say that I do have a bivariate linear relationship going on here that looks like this would be good for regression. So let's check out the other one. The other predictor that we're hypothesizing should predict student perceptions is cognitive ability. But I'm going to show you an older graph process that works well with syntax, so that if you have to make a lot of scatter plots, it's easier to copy paste from syntax. And the way you do that one is you go to Graphs and Legacy Dialogues and come down to Scatter Dot. Here I'm going to choose Simple Scatter and Define. And now I have that dialog box that I'm kind of used to instead of the chart wizard. On the y-axis is the dependent variable all the time. So I want perceptions of research methods at time 2 there. And then I'll put cognitive ability on my x-axis. That's the other predictor that we're hypothesizing about. And here I'll hit paste and go to the syntax window. So calling for a graph, it's a scatter plot, bivariate, with cognitive ability, with perceptions of time, perceptions of research methods at time 2. Like that, I could copy and make a bunch of those. Like whatever I needed to have a bunch of scatter plots on, that would be easy for me to copy, paste, and adjust if you were making bunches of them. I'm going to go ahead and run this. And here's that graph. Now notice it's not as pretty. I didn't get a chance to edit the labels. But if I needed to run bivariate linearity assumption and I just want to find out which of my predictors have a linear relationship with the outcome, I might not want a figure for all of them. So I might just run a bunch of these kinds of just quick scatter plots and then go through the chart builder to build the one that I want to keep and put into my manuscript. I can still put a fit line on this. Linear and turn off the label. Apply and close that, and then close this one. So a slight upward trend. And that's a visual inspection of bivariate linearity, right? What we also want to do is look at the test of bivariate linearity. And the test is just a correlation. We already just did all the correlations. So I want to look at these two. If I go back up to my table and I say, hey, is cognitive ability, that's number 6, is it significantly related to perceptions of research methods? Nope, it's not. So it does not show a test. It does not meet a test of bivariate linearity. Whereas this one, which was conscientiousness with perceptions of research methods, that one is significantly correlated. So it is showing a linear trend. Okay, that's checking out those assumptions. Normality, normal distribution, and bivariate linearity. Once we've checked those initial assumptions for regression, we're ready to start actually running the models. And we're going to run 3. We're going to run a simple bivariate regression, and that just means one predictor, one outcome, which is going to be perceptions of research methods predicted by conscientiousness. And then we're going to run another simple bivariate, and then finally a multiple regression with the 2 predictors and 1 outcome. So to conduct a regression in SPSS, we're going to go to Analyze, Regression, and linear. In here, we need to indicate the dependent variable, which is going to be perceptions of research methods at time 2. And in this independent box, we want our first predictor, conscientiousness. We also want to select confidence intervals for regression coefficients before we paste and run this in syntax. Right here, regression coefficients, confidence intervals, continue, and then paste. And here's our regression that our dependent variable is right there. Our predictor is right there. I'm going to do Control R. And now we have lots of information. We have a model summary, an ANOVA table, and a coefficients table. Now, what do these tell us about the model and about the coefficient, which is the regression coefficient for conscientiousness? Well, I annotated the output here in your lab sheet. This information here in the blue is telling us information about the model. The model says it significantly predicts, which is this significance right here on the ANOVA table, that it predicts perceptions of research methods. So the model is significant, and it significantly predicts the outcome being perceptions of research methods. Here's the significance test, here's the F-test estimate, the degrees of freedom, and the effect size R-square. The coefficients table tells us about the predictor coefficient, the regression coefficients, both the constant or the y-intercept at 4.688 and the slope or the slope of the variable conscientiousness, the predictor, is negative 0.27. So here's the information we're going to need for writing up the regression. We have the model information and the coefficients information. The unstandardized coefficient, this negative 0.27, is for every 1 unit change in conscientiousness, like going from a 4 to a 5, the change in perceptions of research methods will be that much, negative 0.27. We also have the standardized regression coefficient, so it's centered according to the standard error. And then we have the significance test for that regression coefficient, not the model. Even though they're the same right now, they're the same because it's only one predictor. Once we have more than one predictor, these two significance levels will be different. And we have the confidence interval for the unstandardized regression coefficient. So that's this negative 27. It could have been anywhere between negative 519 and negative 021. That's the confidence interval for the unstandardized regression coefficient. All right, let's look at this. We still need some more information to write up or to give the information to the reader about the model and the coefficients. So looking up here, what we want to report, we want to report the test estimate. So the test estimate is this F-test estimate right here. The degrees of freedom are right here, 1 in 72. The significance level of the model and the effect size, which is R squared, is up here. But we still need the confidence interval for R squared, which is not in our SPSS output. We're also going to give an interpretive statement about the model. The information we need from the coefficients are going to be the unstandardized regression coefficient, the significance level, and the effect size or standardized regression coefficient, so that's the beta. Or instead of beta, you can report the confidence interval. So you could report the effect size or the confidence interval or both, but do at least one or the other. But we were still missing this confidence interval for R squared, the effect size of the model. And what I'm going to suggest there is to go to this Daniel Soper website. It's an online calculator. When you get here, you come down to regression, fold that down, and you're looking for R square confidence interval calculator. So in here we have some information we have to put in. We need number of predictors. There's 1. We need the observed R squared. And when we go back to the output, the R square is 0.061. And the sample size. The sample size was way back at the beginning. So Perceptions of Research Methods has a sample size of 74, and that's what we use because that's our outcome, and you have to have two. Like you have to have a relationship between X and Y. If Y is missing, you don't have a relationship. So 74 is our sample size there. I'm going to hit calculate. And here is our 95% confidence interval. Now I'm going to suggest that whenever you see a negative number here, just report it as 0, because R squared doesn't go below 0. So the range of it is not going to go. It's from 0 to 1, the range of R squared. So it doesn't go below 0 anyway. I think it's just how it's calculating. If the lower end is in the negatives, just report 0. Okay, let's see right here. So that's one regression, right? And we have everything we need to write it up. So let's take a look at one more bivariate regression, and then we will look at the write-up for these two single bivariate regressions. So the next one we're going to do is perceptions predicted by cognitive ability. So a new linear model, a new regression with one outcome and one predictor. Analyze, regression, linear. I'm going to take conscientiousness out and put cognitive ability in. Everything else stays the same. I'll hit paste, go to syntax, and run that. So I have my model summary, my ANOVA table, and the coefficients table. For the model, I see that it's not a significant model. 0.190 is not less than 0.05. So the model is not significant. I have my F-test estimate. I have the degrees of freedom. I have my R squared at 0.24. And in the coefficients table, I can see the constant or the y-intercept that I'll need for the prediction equation. And I see that cognitive ability came in at 0.039, so it's positive, but it's not significant. I have my beta, my standardized regression coefficient, as an effect size of of the coefficient test estimate, and I have my confidence interval for the 039. It could have been as low as negative 0.20 or as high as 0.098. And notice because it's crossing zero, it goes from negative to positive, it could have been nothing. So it's not a significant predictor. So let's look at the write-up itself, and then we'll come back to this multiple regression. In the lab write-up example here, the first paragraph is all about those preliminary analyses, like what the study variables were, what they were about. You can tell your reader to go check out the correlation table, and you tell the reader about your visual examination of the study variables regarding normality and any kind of violations. We also mentioned the significant correlation test between conscientiousness and perceptions of research methods, because that's directly related to the regression that's going to be run next. You have shown bivariate linearity by the test and also by looking at the scatter plot. And then a good way to just close off that preliminary paragraph is to let the reader know you're moving on with analyses. Analysis continued with 2 separate bivariate regressions and a multiple regression. And then when you get to your regressions, each test goes in its own paragraph. So every time you run an analysis, it has information in it, like what test was run, with what variables, like student perceptions of research methods and conscientiousness. You give the results of that test and the stats line that goes with that result. And it's good to have an interpretive statement about what you just said about the results. So right there in the first part, we're saying what test or what analysis, a linear regression, and what variables. Results indicated a significant model, and there's the stats line, that it was an F test. There's the degrees of freedom, the 1 in 72. The F test estimate was 4.66. The p-value for the model was 0.034. R squared 0.061, and the 95% confidence interval. I have it highlighted here to remind me to tell you to just use 0 if it's going into negative on the Daniel Soper site. And also, you'll find that the confidence interval for R squared, when we run it in R Studio, is not exactly the same as the Daniel Soper online calculator. Don't worry about it. I know that they're different. It's just the way they're doing the math. And they're still going to be pretty close. So it's just a little highlight to remind me to let you know that. Here is an interpretive sentence. According to the results and this R squared, this tells us the proportion of explanation of variation in the outcome due to the model. So approximately 6.1% of variation in students' perceptions of research methods, the outcome, was explained by the regression model. So that's all about the model. The next sentence goes into talking about the specific predictor. So you first tell the reader about the model, and then you tell them about the predictors. Conscientiousness was a significant predictor, and then there's the stats line for that predictor. The unstandardized regression coefficient, the significance value. Beta is the effect size. It's a standardized regression coefficient. And then the confidence interval for that unstandardized regression coefficient. Here's an interpretive sentence. For each 1 point increase in conscientiousness, that's the predictor, predicted a 0.27 decrease in students' perceptions of research methods. So you're kind of breaking it down for the reader. Instead of them trying to decipher that stats line, you're letting them know, what does this mean? Or what kind of impact might this predictor have? Well, a 1 point change in conscientiousness will have a negative 0.27 change on the outcome. And then this is our prediction equation. Perceptions with the little apostrophe or prime means it's being predicted. It's not the actual measure of perceptions. It's saying we're predicting this is what the level of perceptions, the outcome variable would be, given that the y-intercept or the constant, if conscientiousness was 0, you would still have a 4.69 for perceptions. But for every 1 unit of conscientiousness in the case, in the data, they were seeing a negative 0.27 on perceptions. So it would be, if it was 1, if conscientiousness was 1, then that's 4.69 minus the 0.27. But if conscientiousness was 2, we'd have to multiply 0.27 by 2 and then subtract that from 469. So it's just plugging in what value conscientiousness would be. Tells us the predictive likelihood of that outcome. Okay, and then the second paragraph is about the next model, the model that was not significant. So when we had a regression using cognitive ability as the single predictor with 1 outcome, the model was non-significant. We still give the stats line for the model, and we still let the reader know, but we let them know that cognitive ability was not a significant predictor, and we don't need a prediction equation because the model is not predicting, it's not significant. But we give the reader the information about the model as far as the stats line and about the predictor of cognitive ability. Okay, so let's go back up to the multiple regression right here. So now we're going to have 2 predictors on that 1 outcome of perceptions of research methods. Here, we'll go over to Analyze, Regression, and Linear. And we want conscientiousness in here too. And I'm going to put it first and then cognitive ability second. It doesn't matter which one you put first or second. They're both going in at the same time on this. I'm going to leave the statistics at confidence intervals and then paste. Going over to syntax, we have both of our predictors and our dependent variable. Got our model summary, our ANOVA table, and now our coefficients table has 2 predictors and the constant or y-intercept. And I have annotated this on your lab sheet. The model, we see that it's a significant model. We have our F-test estimate and the degrees of freedom for the F-test. And the effect size, the R-squared at 11.112. That's the information we need about the model. For the coefficients, we need to know the y-intercept, we need to know the impact of each of these predictors. So conscientiousness is significant at 0.010, and for every 1 unit change in conscientiousness, perceptions of research methods would decrease by 0.34. So it's actually stronger now than it was by itself. Cognitive ability at 0.060 positive is also a significant predictor when it's in the model with conscientiousness there. So 0.047 is less than 0.05. So this is the information we need for the coefficients part of the write-up. I'm going to scroll down to that write-up part. A multiple regression was conducted to examine if conscientiousness and cognitive ability would predict students' perceptions of research methods. So we said what analysis is taking place. We said what variables are involved. The results indicated a significant model. Make it clear. What did the results find? Give the reader a stats line so that they have what test was being used, what the degrees of freedom were, what the F-test estimate was, the significance level, the effect size, R-squared is what we use for regressions, and the confidence interval for R-squared, which you get on by filling out that online calculator. And again, so we have 2, we still have 74 sample size, and the R-square was 0.112. So if we go 0.112, calculate. So we still have a negative number there, so just put 0. And here 242, if I'm rounding to hundredths or thousandths place. The 258 is because that's what I got out of R. I tend to trust R better on calculating the R-squared confidence interval because it doesn't go into negative numbers. But like I said, either one is fine. I know that they report differently. But that 11.2, that from your R-square, you convert that to a percentage, that tells you the variation in the outcome due to the model. Not due to each, you can't say due to the predictors. It's the whole model that's predicting that much variation or explaining that much variation in the outcome. Then you go into talking about your regression coefficients. Conscientiousness was a significant predictor. There's the information for it. Each 1 point increase in conscientiousness had a decrease in research methods. Cognitive ability was also a significant predictor. Every 1 point increase in cognitive ability predicted a 0.06 increase in students' perceptions of research methods. So the unstandardized regression weight is what tells you about the change in the outcome for every 1 point increase or 1 unit increase in the predictor. But now we have a more interesting prediction equation. Perceptions predicted, so always remember to do your apostrophe or prime symbol, is the y-intercept minus what was contributed from the conscientiousness predictor plus the contribution of the cognitive ability predictor. And I think that's all we have here. Yes. The only thing past this is the examples of a figure. And if you wanted the table, it's the one we made earlier. Right there. Alrighty. So what did we do? Our goals for the lab were to describe the study variables by also including a correlation table, we're already describing them, the continuous variables with mean and standard deviation, but here we're putting the relationships between the continuous study variables all on one table so that the reader has one summary place to look at. Now, anything that was significantly related to the outcome, the dependent variable that we're going to be using for our regression model, you want to also notify the reader about that in the narrative. We evaluated the assumptions of regression, specifically normality of the predictors and the bivariate linearity, and we conducted 3 regressions and looked at the results to gather the relevant information to communicate those findings. So have fun with that, and I'll see you in class.